Another question that I have is convert 1 joule into ergs. So to convert 1 joule into ergs, we are going to use the dimension method. So the given physical quantity is work. The symbol of work is W. The dimensional formula of work is ml squared t minus 2, and comparing it with m to the power a, l to the power b, t to the power c, we get a is equals to 1, b is equals to 2, and c is equals to minus 2. So now let 1 joule equals to n ergs, where n is a random variable that we are supposing right now. So now in MKS system, and we have the MKS system or the SI system, and we have the CGS system. Even though I'm saying MKS and SI system interchangeably, that sounded wrong, but you get what I'm saying. MKS and SI are pretty similar that you can say they are equivalent, but they are not the same. Okay, they are not the same. MKS has only 3 fundamental units, whereas SI has 7 fundamental units, and also SI has 2 supplementary units, which MKS does not have. That is something to know about MKS and SI system, but they are basically same. Okay, so here M1 is 1 kilogram, L1 is 1 meter, T1 is 1 second, N1 is 1. So it does not have to be 1 actually. So if it was 10 joules, you would have N1 to be 10. It's just that we have chosen 1 joule, that's why it's 1. So here M2 will be 1 gram, L2 will be 1 centimeter, T2 will be 1 second, and N2 will be N. So if you ever get confused on the units, just see the name. C meaning centimeter, G meaning gram, S meaning second, and here in MKS as well, M meaning meter, K meaning kilogram, and S meaning second. Pretty easy, right? So then we have the formula that we have to do it dimensionally is N2 is equals to N1, M1 by M2 to the power A, L1 by L2 to the power B, T1 by T2 to the power C. So let's do it. I did something. What did I do? I think I got a video. Anyway, so let's add some brackets, right? You gotta make them pretty. So this is the formula. If you want to remember it, because it's a pretty handy formula. And if you watched the previous video, you also learned to do it by an easier way and a much more intuitive way, as well as a quicker way. I showed you 3 ways, and in this video I'm not gonna show 3 ways. Okay, so let's do it just by dimension method. So N1 is gonna be 1, and M1 is actually 1 kilogram, M2 is 1 gram, and we are dividing it to the power 1. We are raising it to the power 1. So again, for length it's 1 meter divided by 1 centimeter, and here it's 1 second divided by 1 second. B is 2, and this is minus 2. So let's just add some brackets. They are supposed to be square brackets, but I'm making them round brackets because I don't have a shape that is a square bracket, so make do with this one. Okay, so now Let's convert them to make it easier. So n to 1. So 1 kilogram is 1,000 grams. 1,000 grams divided by 1 gram, and 1 meter is 100 centimeter divided by 1 centimeter. 1 second is 1 second. Yeah, nothing more to say about that. So let's add the brackets. So if you see, the units actually cancel out right now. So you might be thinking, why is the units being cancelled out? I mean, aren't they attached to the number? They are not attached to the number actually, because if you remember, a physical quantity is represented by nu, where n is the numeric part and u is the unit. So the unit can be actually cancelled. So cancelling the units, and you can also cancel the 1, but I'm not gonna do that. So now we can do some easy calculations. Now it's just easy calculations. N2 will be 1 times 1000 times 100 square, which is actually it will, okay, let's write it in the next line. 1. So N2 is 1 times 1000. So when multiplying 100 into 100, you can write it as 100 into 100, which means instead of 2 zeros there will be 4 zeros. So when squaring, the zeros, the number of zeros just becomes double. So here N2 will be 1. So let's count the number of zeros. 1 2 3 4 5 6 7. So we can write this as 10 to the power 7. So N2 is n, so n is 10 to the power 7. So finally we can write 1 joule as 10 to the power 7 ergs. So we found what 1 joule will be in ergs even without knowing anything. That's very cool, isn't it? So in the next video we are gonna learn about the next application of dimensional analysis, which is to find dimensions of a constant in a relation. So bye bye.